Okay, another experimentation question talking about lifting a weight through a height using a pulley and a motor. Give one variable that was controlled. Okay, so that would be, the easiest ones would be weight of weight. Weight of weight, or the height travelled. Okay, they're important. Okay, there's other things like how warm the room was and stuff like that, but you've got to go for the important ones, okay? Give 2 readings for taking repeats in the investigation. Is to calculate an average. And identify any anomalies. It doesn't, lots of you put that it makes it a fair test. Not necessarily. You do it 100 times unfairly, that doesn't make it any better. Okay, so you've got to be careful about the terminology that you're using. So again, interpretation of results. Okay, as speed increases, efficiency increases. Okay, don't start saying you can't make any proportionality because it's not straight. So be careful there, and it appears to be levelling off. Okay, so there's almost, if we carried on, it's going to flatten out and we're going to get a maximum efficiency. Okay, so that's what it appears it's going to do, and that's all we can do in terms of the data that we've been given. The main way will be heat lost due to friction, not sound. Okay, it will make a noise, but that's not the main way. Okay, and when the total power input to the motor was 5 watts, the motor could not lift. Okay, so it could not do its job, and therefore it was 0% efficient. Caught a few of you out that you tried to do calculations, and it's a calculation you simply couldn't do. So, circuits again, as just discussing, we've tested you more than once on every area, so this is really thorough about what you can and can't do. Calculate the potential difference across. The only thing here is no equation given, doesn't say go and find it anywhere, you just expected to know it, and then it's simply the current multiplied by the resistance. Do I have to do anything with significant figures? No, I don't. So I just put the number in here and I've got the solution. So there is 4.5 volts there. Calculate the resistance of the resistor labelled R. Now this is quite difficult actually, because in an earlier question we turned, so we've got R and 60 and 45 all in a line, and therefore the value of it, if it was one resistor, would be R plus 105, because we were trying to add them all together. So the resistance total, okay, V equals IR again, the total at the top is 12 volts, and that's equal to the current, which is 0.1, because it's in series, multiplied by the total resistance. Okay, so this is mathematically difficult, and you've got to recall the equation. So that means 120 is equal to R plus 105. So R is 15. That's really difficult, really hard. Loads to do there. Recall the equation. Remember all this stuff, or linked up just up here, just off the screen, and then do the calculation. State what happens to the resistance of the circuit and the current. Lots of people only talked about one or the other. So the resistance goes down. That's good. So the current goes up. lots of people talking about path of least resistance and stuff like that, so that was really encouraging, but didn't mention remember 2 marks, 2 requisites. This is what they want you to talk about, so you need to work through that. Okay, another one on circuits, but again, more analysis of graphical work, but again, it's a practical you should have done. Draw the circuit, so you can see again how it's harder from the previous one, the components aren't given, so you need an ammeter, you need the thing. Okay, you can't test both bulbs at the same time, and you need some method of variation, otherwise you don't get readings, you just get one measurement and then there. Okay, so these 3 in series with one another, and then always in parallel across the thing you're having a look at. Which lamp will be brighter at any potential difference? Well, brightness is all to do with the power, which is equal to V times I. Okay. Now if we look at the graph, at any potential, the current is higher for A than B, and therefore the power will be bigger than in A than B, and therefore it will be brighter. So it's lamp A because I for any V is higher, so power is higher. Bullet point even little tiny sentences, okay? Because that way you're breaking your answer down into more logic. Lamp B has a higher resistance at any potential difference. Explain how that shows that. At all voltages, current is lower. So resistance must be higher. So that's difficult, this part of the question, because I'm talking about power in this question and I'm talking about resistance in this question, but I'm relating it in both cases. This is P and I and this is R and I. Okay, so that's quite difficult because I'm flip-flopping between 2 ideas. And both lamps behave like ohmic conductors through a range of values of PD, not current. Okay, use figure T. So the range for both, voltage range for both, and nobody got this right I think, is between 0 and 2 amps. Now why is that? Because ohmic conductors have straight lines. I don't know why I'm writing this here. So ohmic is when the graph is straight. It's the same voltages for both. Right, I'm speeding up, this is good. So, student, this is the first time we talked about energy really in terms of gravitational and elastic and well, we'll look at the equations as we go through, but loads of data. So unstretched, it's 20 metres. At its lowest point, it's 55 metres long, which means it's stretched, or extension is 35 metres. Don't be afraid of annotating diagrams, okay? Because that'll help us. We've got a mass, we've got gravity. Right, we're off. GPE is equal to mg delta h. So mass times gravity times change in height. Calculate the change. In fact, that should be a change as well. Okay. So this one's quite straightforward. Delta GPE is equal to 50 times 9.8 times 20, and that, when you chuck it into a calculator, gives you 9,800 joules. Do we have to do anything with our significant figures? No. 80% of this gravitational potential energy is being transferred to students' kinetic energy store. How much? So it's just 80% of 9,800, which is equal to 0.8 times 9,800, which is equal to 7,840 joules. So give the speed of the student after falling 20 metres. Again, loads to do here, 4 marker. Okay. Kinetic energy is equal to half mv squared. Half times mass times velocity squared. The student has 8,470 kinetic joules of kinetic energy. The mass is 50 and the velocity is unknown. Okay. What I would do is I would simplify this with numbers as much as possible. Rather than doing algebraic manipulation. So V is equal to 17.7 meters per second. Okay. But, so that's hard. Recalling the equation, rearranging the equation, putting the numbers in, and then there is something to do with significance. So loads and loads of stages to that question. Lowest point in the jump, the energy stored in the stretch bungee is 24.5 kilojoules. Loads of you missed off the fact that that means it's 24,500 joules. Got to get rid of those. Got to get rid of those prefixes. So therefore, that the energy, what we have to, is equal to half times k times e squared. So it's energy. This one is spring constant, and that's what we're after. And E is extension. So it's 24,500 is half times K times 35. That's how far it's stretched. Okay? So 24 over half times 35 squared to K. So that's equal to 40 newtons per metre. Nothing to do with significant figures or anything like that. Difficult question that though.